All right, welcome. Today we are talking about line segments and distance. So this is actually a pretty simple concept. So the main postulate that we're using is the segment addition postulate. So basically what that says is that if I have two line segments, I can take their lengths, add them together, and make a bigger line segment, right? So in other words, if I'm looking at these examples, right, it tells us to find the following measures. So for part A, we need to find the length of EG. Another way to think of this is I'm trying to figure out the distance from point E to point G. I know that the distance from E to F is 2 3/4. I know that the distance between F and G is 2 3/4. So if I want the distance all the way from E to G, all I'm going to do is add those two lengths together. And we can do this on our calculators. If you hit alpha, y equals, it brings up a little menu. If you pick that second one with the u f over d, it'll bring up a mixed number. So you can literally just type it in the way that you see it, and it'll give you an answer. Right, so again, what you're going to type is alpha. Then you're going to hit y equals. And then you're going to pick the one that looks like this. So that's how we're going to get a mixed number. Our calculator will fill in the rest for us. You basically fill in the boxes, and you'll be good to go. Alright, so for this next one, we need the length from A to B. We notice that we have 13.2 as the length from A to C, and we have 5.8 as the length from B to C. So the only difference between this problem and the one we just did is that we're going to have to kind of think of it backwards, right? So let's say I don't know this. I know if I add the AB distance and the BC distance, it should equal to the total distance. Now, I can find my x. Right, so we're just going to subtract 5.8 on both sides. So if I take my calculator and do 13.2 minus 5.8, I get x equals 7.4. So the way that we're going to write this is AB equals 7.4. So for the first one, I should have noted that EG equals 11/2. That is how we add segments. Here's a couple of examples for you to work on your own. Alright, so for this next one, again, we're going back to segment addition. This time, though, notice they gave us an equation and they want us to solve for the missing variable. So we know that the two smaller pieces, right? So we know that x to y plus y to z should add up to 5a minus 4, or x to z. So if we're writing that out, x to y plus y to z is the same as x to z. The problem tells me that x to y is 3a. It tells me that y to z is 14. And it tells me that x to z is 5a minus 4. So now we're just going to solve it like a normal algebra equation, right? So we're going to subtract the 14. So we get 3a equals to 5a minus 18. Subtract that 5a. Right over here. So it gives me negative 2a. It's equal to negative 18. So when we divide out the negative 2, we'll get to a equals 9. If we go back to the original instructions, we were just looking for the value of a, so we've given them what they want. All right, so for the next example, I'm going to let you try it on your own. I'm going to suggest that you draw a picture that looks just like the one from question 1, right? So draw out the line, place the points in order, fill in the equations as they've given to you, and that should help you with your setup. All right, so now let's look at distance as it comes to a number line. It's basically going to work the same way, only now we're going to have to either count the points or subtract the endpoints to figure out how far apart they are, right? So for part A, it says find BE. You need to locate point B. There's point E. If I want to know how far apart they are, I can either just count the spaces. So 1, 2, 3, 4, 5, 6, 7, 8. Or, if I'm trying to be efficient, I can say that the distance from B to E is equal to 2 minus negative 6. In other words, I take the final point minus the starting point. So notice either way, I get 8. That's my answer. For part B, we want to determine whether CA and ED are congruent. Right? So congruent means they are the same length. Let's clean that up. So same length. Right? Congruent figures are exactly the same in every way. The symbol for congruent looks like an equal sign with a little squiggly on top. So this is the geometric version of equals. So all we're going to do is figure out the length of CE. So C to E is equal to 2 minus negative 4. So that gives us 6. The length from E to D is 2 minus negative 2. There's only 4. 4 does not equal 6. Again, when we put a line through it, it means not. Therefore, CD is not congruent to ED. All right, so again, use that same number line to answer 3A and 3B. Let's move on to our last example. Okay, so you should have seen this last year. This is our distance formula, right? So if they give us coordinates, all we're going to do is plug into the formula, calculate the answer. So if I want the length from C to D, it's going to be the square root of x2 minus x1. So here's my x2, here's my x1. So 5 minus negative 4 squared. Then here's my y2, here's my y1. So negative 1 minus negative 6 squared. Then I'm just going to type that into my calculator exactly as I see it. It's going to give me 10.296 if I round it off to 3 places. And for B, same thing. So the length from M to N is the square root of x2 minus x1, so negative 3 minus 2 squared plus y2 minus y1, so negative 2 minus 4 squared. We're going to type it in to get our answer exactly as we see it. That includes the parentheses. We should get about 7.81 if we round it off. That are our examples for today. See you guys next time.